Alrighty. Oops, this is the assignment. Alrighty, assignment 2.2, packets and frames. Just like the other video, I'm going to do the exact same stuff, honestly, because I'm unoriginal. So we're going over packets and frames, which is actually a lot shorter than the OSI model. And okay, packet and frames are essentially like a mailing letter process. The envelope is the frame, the letter inside is the packet. When the recipient opens the frame, they will know how to forward the packet. Packets are pieces of data from the network layer, and they contain IP, header, and payload. It's an efficient way of communicating data across network devices and less chance of bottlenecking occurs. And while frames are used in the data link layer, they encapsulate the packets and add information, such as the MAC address, which was gone over in test 1. Gotta love the little notable headers right here, such as time to live, checksum, source address, and destination address. Now, the TCP/IP three-way handshake. Real funny, real long. As we know, the TCP is a transmission control protocol, and it has the connection based and must establish a connection between both the client and device acting as a server before the data is sent. It lists the advantages and disadvantages of TCP and gives us a couple more headers that are real helpful, such as the source port, destination port, source IP, destination IP, sequence number, acknowledgement number, checksum data, and a flag. Now, the three-way handshake is this process that highlights a certain couple of things that will help us with understanding how the connection is established between two devices. So we have the SYN message, which is the initial packet, then the SYN ACK, so we acknowledge about the synchronization, ACK, which is acknowledgement, data, SYN, and any packet that abruptly ends all communication, such as the server not working, system has faults, or the Wi-Fi breaks it, I guess. It would be under this RST. So this diagram right here shows how it'll work. SYN, SYNAC, ACK. All fun, all good. Another little over here. And it goes in a numbering system used in coding, where it starts at 0, 1, 2 instead of 1, 2, 3. When TCP closes a connection, we'll have that SYN, ACK SYN, and then another ACK. Now it shows us a little practical piece right here. I'll actually come back to that as we have the UDP/IP. It goes over UDP and a couple different headers that we've already seen. And it shows how it is a stateless type of connection. No acknowledgement is sent during this. We got the request and a couple of responses without any acknowledgement. TCP would be used to transfer file, and UDP as a video call, just kind of as examples given through the try hack me. Now we're going to scroll back up and go over the practicals, such as the handshake. It keeps freaking. There we go. Hopefully, I don't get that. So we have SYN, SYN ACK, ACK. Then we have our data, acknowledgement, SYN ACK, SYN ACK, and another acknowledgement. A lot of it has to do with the acknowledgements. Then we have ports, practical, and it'll tell us what to view. So if we type in the IP at almost like that, with 8.8.8.8 on port 1, 2, 3, 4, which as our example calls, we'll get the flag, hopefully, that connection was received. However, this wouldn't work if I did it on a different port, such as 2, 3, 4, 5. Just wouldn't work. Okay, no contact. And that was our walkthrough of packets and frames.